Lesson 40 discusses the units of the derivative, normal lines, and then maximums and minimums on a graphing calculator. So we'll start with the units of the derivative, and we know the derivative finds slope or measures slope, which is rise over run. And when the variables represent actual quantities, like when our x-axis might represent time and our y-axis distance or some other thing that you're measuring, that rise over run represents values that have meaning to them. So your dependent variable over the independent variable. So here in this statement here, it says the unit of derivative of a function is the unit of the dependent or vertical divided by the unit of the independent variable or the horizontal axis. And so that's going to be helpful in many different situations. We'll be looking at some physics types questions here. So example 1, the distance, s, of the particle from the origin is given by the equation s equals t squared plus 3t plus 7, where s is measured in meters and t is in minutes. What is the rate of change of the distance with respect to time when time equals 4 minutes? So what's the rate of change of distance with respect to time? That's a change in distance over a change in time. Well, our function here, s, represents the distance, and t is the time in minutes. So we have that s equals t squared plus 3t plus 7. And so if we want to find the change in distance over change in time, we just find the derivative. So we have ds dt, change in distance over change in time. Well, ds dt is the derivative, so 2t plus 3. And then we want to evaluate this at 4 minutes. So ds dt evaluated when t is equal to 4 is going to be 2 times 4 plus 3, which is 7. And thinking through that, that is 7 meters per minute if we look through what our units are. So the rate of change of meters per minute is 7. The next part, still in the idea of physics, the velocity of a particle in meters per second is given by the quadratic equation v equals 4t squared plus 2t plus 4, where time is in seconds. What's the acceleration? Well, if you know anything about physics, you know acceleration is the rate of change of the velocity. So acceleration is kind of our meters per second over seconds in this case. You don't always have to have meters and seconds. It could be other types of measurement, but it's the change in velocity over a period of time. Well, if we simplify this unit, this ends up being meters per second squared, which if we first looked at that, we wouldn't necessarily realize that that's acceleration, but it is meters per second squared because it's meters per second per second. So if we take our velocity function and we find the derivative, that is going to give us our acceleration. And so this is 8t plus 2. And we can evaluate that because we want to know what's the acceleration at 3 seconds. So we can put in 3 at t equals 3. And that is going to be 8 times 3 plus 2, which is 26 meters per second squared. So not a hard part of the lesson, but very necessary as we move forward through calculus and using it for some real life application. All right, next is also something that's fairly familiar to us because we did something similar to this before, but normal means perpendicular, so we're going to be talking about normal lines or perpendicular lines. So how are the slopes of perpendicular lines related? We know that they are negative reciprocals. So earlier on, we were able to find equations of tangent lines to a curve, and now what we're going to do is we're going to find the equation of a normal line to a curve. We're going to use the derivative still, but since it's a normal line, that means perpendicular, which means we're going to do the negative reciprocal of the slope. So it's going to look a lot like what we've done before, except we'll have to take the negative reciprocal once we find the slope. So in order to write the equation of a line, we need a point. Well, to find the point, the function is y equals e to the x, and we want to know or find this line when x equals 1, so we put 1 into our function. So y equals e to the first. So our point is 1e. And then we need the slope. Well, the slope of a tangent line to the curve at any point on the curve is the derivative, so y prime is still e to the x, because the derivative of e to the x is e to the x. And we want to take the negative reciprocal of that. So the perpendicular slope is going to be negative 1 over e to the x. And we want to still put in when x is equal to 1. So that's 1, or negative 1 over e to the first. And now we can do the equation of the line. We can do y minus e equals our slope, which is negative 1 over e, x minus 1. Distributing gives us negative 1 over e x plus 1 over e, and then we can add e to both sides. And we get the equation, negative 1 over e x plus 1 over e plus e. So there's our slope, and there is the y-intercept.